Unit 6, Day 3. Today we're going to continue our discussion on parallel lines and proportional parts, as well as talk about some new information in it, including mid-segments. The first things we're going to talk about is other ways that we can prove two triangles are similar. The first way being angle-angle similarity postulate. Essentially, all you need is two corresponding angles indicated congruent across two triangles, and that is enough information to prove that two triangles are similar. The second way is the side-side-side similarity theorem. Essentially, you have corresponding sides like JL and MQ, and the ratio between all pairs of corresponding sides would need to be equivalent. And if all three ratios are equivalent, then the triangles are similar, which is what we did on day 1 to prove that those few examples and those homework problems are similar. You had to find all three ratios and see if they were equivalent. And then we also have the side angle side similarity theorem. On this one, you just need two corresponding sides to be proportional and an included angle. Included, we talked about the meaning of that earlier this year, but if you read it side angle side, you should notice that the word angle is between the two sides. So included just simply means between. So in the pictures, the congruent angle is between the two proportional sides. So included between. So this first few examples, they want us to determine if the triangles are similar. If they are, write the similarity statement. And let's explain our reason. So on the first example, the triangle on the left, ABC, shows us two sides and an included angle. The triangle on the right, DEF, shows us two sides, but the angle is not included. However, because it is a right triangle and we do have two sides given, we can find the other side, EF, using Pythagorean's theorem. So let's do that first. Pythagorean's theorem again is a squared plus b squared equals c squared. A and B are the legs, and C is always across from the right angle. So I would now say that 6 squared plus b squared is equal to 10 squared. 6 squared is 36. 10 squared is 100. To get b by itself, I would subtract 36. So I would have b squared is equal to 64. And then if I want b, not b squared, the next step is to square root both sides. So b is equal to 8. So now I have 6 and 8 with an included right angle. Next thing I would have to do is test proportionality by setting up ratios. So side AB is the smallest side on the right triangle, the left triangle. So it would correspond with DF because it's the smallest side on the right. And then AC would correspond with EF because they're the second largest side on this triangles. So now I would set up the ratios. So AB is to FD. So that means 3 is to 6, and that reduces to 1/2. Then I would check the ratio for the other proportional sides or corresponding sides. So AC is to FE. So AC is 4, FE is 8, and that reduces to 1/2 as well. So yes, we would, since the ratios are the same, those two sides are proportional. So we have two sides and an included congruent angle. So yes, these triangles are similar. So we would write the similarity statement. I'm running out of space, unfortunately. So I will write it over here. The similarity statement for number 1 would be triangle ABC is similar to triangle FDE. Remember, you got to match up the corresponding angles, so be careful with that. And our reason that these two are similar is by the side angle side postulate, or I'm sorry, theorem. All right, let's jump down to number 3. Again, we are given all sides now. So perhaps it might be side, 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 but we would have to check the ratios. So the first thing I would do is highlight the corresponding parts. All right, the smallest side on the left is TU. Whoa. So it would correspond with HG on the right. The next small, the next largest would be 8 on the left with 5 on the right. And then that leaves 12 on the left and 8 on the right. So let's set up the ratios since we don't have any angles. So we would say TV is to FG. So 8 is to 5, and that's reduced as best as it can. So now I would say TU to HG. TU is 6, HG is 4. That reduces to 3/2. Already, they're not matching. So we technically don't need to go any further. So we would have to say no. The triangles are not similar. And it's because the sides are not proportional. The ratios that we just found are not the same, so the sides are not proportional. I will leave you to work on number 2 and 4 on your own. On the next 4 examples, they want us to set up a proportion for the following situations. It doesn't want us to solve. And it says it might be helpful to write the similarity statement first. So on example 5, in this scenario, what I would do is separate the two triangles. If I were you, you have triangle RST which is the smaller one, and QSV, which is the bigger one. So clearly you already see two right angles that are congruent. And then they both involve angle S in the same spot, so angle S is also congruent. So it would be triangle, you could say TSR, right angle, the S and R is similar to triangle VSQ, if that helps. So now that I know that, and I just simply know that they have two congruent angles, and that's enough to write the similarity statement, the AA postulate. Now that I know they're similar, I know that the sides are proportional. So I could write a ratio using 5 and 3 who correspond. So 5 is to 3 as, and then we see that this 12 down at the bottom corresponds with x. So I would say x on the top because it's from the larger triangle, like 5 is, with 12 at the bottom. So that's one setup that would work in this situation. On number 7, it has two angles already marked congruent, but you should always recognize bow ties whenever you see them. So let's go ahead and mark them congruent. So that means J corresponds to P and L corresponds to itself, which would leave K and M. So those would be the name of the triangle and the similarity statement. So again, you have two angles, which is enough information to say that they're similar. So now that I know that, I'm going to highlight the corresponding sides. So we have JL right here, which is 4. It corresponds to PL. And then JK corresponds to PM. So now that I know my two corresponding sides, I can set up my ratio. I could say x is to 12 as 4 is to 6. There's other ways to set up that proportion, but make sure you do it correctly. So go ahead and answer number 6 and number 8 on your own. Again, all you're doing is setting up a proper proportion. That is the hardest thing on your upcoming tests. You have to know how to set up a correct proportion, so that's why we need to practice it a little more. Now we're going to talk about the midsegment. The midsegment of a triangle is a segment with endpoints that are the midpoints of two sides of the triangle. Every triangle has 3 midpoints. So on this picture, we have RQ is a midpoint because point R, I'm sorry, RQ is a midsegment because R is the midpoint of A to C, and Q is the midpoint of B to C. Then QP is a different Midsegment. P would be the midpoint of A to B, and Q would be the midpoint again of C to B. And lastly, we have RP as a midsegment. So again, a midsegment has endpoints that are midpoints, essentially. Now let's talk about the midsegment theorem. A midsegment of a triangle is parallel to one side of a triangle, and its length is one half the side of that triangle. So the length of the midsegment is one half the length of the side that it is parallel to. So in other words, JK on this picture is your midsegment, and JK will equal half the value or the length of FG. Okay? Another way to look at it is if I were to multiply by 2 on both sides of this equation, I would create a new equation. I could say 2 times JK is equal to FG. So it's good to have both of those equations in your toolbox because they'll become very handy in just a moment. So the sum version, mid-segment is equal to half parallel side, or you could say parallel side is equal to 2 times the mid-segment. That's a summary of what just happened in Theorem 7.7. So let's practice this. In the figure below, it says that x, y, and xz are midsegments. So let's highlight those real quickly. So xy is a midsegment. So just knowing that information, I know that point x is a midpoint. So r to x is congruent with x to s. And then I know that point y is a midpoint as well. So that means r to y is congruent with y to t. All right. Now, and then it also mentioned, that xz is a midpoint as well. I've already marked the side that x is on congruent. Now I need to do that for the side z is on. So I would need 3 tallies. So s to z is the same as z to t. They're congruent. Now, if you look at the picture very carefully, I'm given the distance from r to t. It's 13. And xz is parallel to rt. So, since xz is parallel to it, and xz is the midsegment, I would say that xz is going to equal 1/2 of rt. In other words, it's going to equal 1/2 of 13, which is 6.5. Sorry. Had a brain fart for a second. Because, like I told you in the summary in the previous slide, mid-segment is equal to half of parallel side. All right. Now, On number 10, it wants us to find ST. I will help you set it up, but you should be able to figure it out with a few hints. ST is parallel to XY, and XY is the midsegment, and it's 7. So now figure out the value of ST. That's all I'm going to tell you. Good luck and work it out on your own. This concludes your notes for today.